Okay, guys, let's get back to our sequences. If you recall, we had two formulas already that we've learned. A sub n equals a sub 1 plus n minus 1 d. A sub 1 is the first term, d is the common difference, and that's for arithmetic sequences. So if you want to find the generator for arithmetic sequence, you use this formula here. That'll find the 30th term, the 50th term, whenever you want. Then we can have a different type of sequence called the geometric sequence. A geometric sequence has a common ratio. If the common ratio is a multiplier to each term in the sequence to generate the sequence. And that is the first term times the common ratio n minus raised to the n minus 1. And that's for geometric sequence. Now we're going to continue on, and we're going to see, we're not going to find the term, we're going to find what all the terms add up to be. Arithmetic series. It's kind of like the World Series. How many games was it played in? We're looking at all of them. So therefore, the arithmetic series right here, in many situations, you want to know the sum of the terms in the sequence. Now we're going to add them all together, and you'll see examples that'll come up in a minute. So in many situations, we want to see the sum of the terms in the sequence. The sum of the terms of the arithmetic sequence is called an arithmetic series. So let's check one out right now. Okay. Oops, apologize for that. Okay. So, real quickly, let's take a look at this. We're going to add the numbers from 1 to 100. I want you to find their sum. So, in other words, in order to add the numbers from 1 to 100, we're going to take the number, magic pen, take the number 1 plus the next number, 2. So we're up to 3, plus the next number 3. So that would give us 3, 4, 5, 6, plus the next number 4. And we want to add them. We put dot, 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 and then we're going to get to 95, 96, 97, 98, 99, 100. Okay, you might think this is a tedious problem, but a long time ago, supposedly, the rumor has it there was a math guru by the name of Gauss. He was in the classroom and he was bothering the elementary teachers. And she kicked him out of the room and told him to add the numbers from 1 to 100. He went out of the room for about 10 seconds, came back with the answer. How did Gauss do that so fast without a calculator way back when, 100 years ago? So, he came up with an idea. If I want to add all these numbers, he saw a pattern. Okay, very genius idea he came up with. So let's see what kind of pattern he saw. So I'll speed this up a little bit. I usually have fun in the classroom doing this, but unfortunately, can't do it that way. He saw if you take the first term in the sequence and add it to the last term, you made a number 101. You take the next term in the sequence, the 2, add it to the number 99. You get 101. If you take the next number in the sequence, let's use blue, 3, add it to 98, you get 101. So he saw that if he took the first term in the sequence and the last term in the sequence, you got 101. So he saw that he got 101. And then he realized that since there's 100 numbers, he had how many pairs? 101, that, 99 and 2 is 101. So he realized, wait a minute, if he divided this whole thing by 2, he would have 50 pairs of 101s. So then he multiplied 50 times 101, which you could do it as a shortcut. It'll be 550, okay? But if you want to check it on the calculators, I highly suggest it. So you do 50 times 101, and you'll get 5,050. And that's the answer. And that's what Gauss came up with, supposedly, when he was in like elementary school. So, is there a pattern? Absolutely. In order to find the sum, he took what? He took the first term in the sequence plus the last term in the sequence. He added them together. First term plus the last term. And he's divided how many terms? He divided how many terms by 2. And that's his philosophy how to do that. I'm going to give you the formal definition. But before we go down there, I want to talk about the summation symbol up here. Okay? This is something that you should be familiar with. It's a capital sigma. It's the summation symbol. I know you've seen it before. So let's just take a look at it real quick. This here says the same thing. Okay? That says the same thing as what we just did. So if you take a look at this, how does this work? You would start here at 1. That's your starter value. You start at 1. So you put 1 here for n. So we write 1. Then we say, did we reach 100? That is your end. That's where you end. No, we didn't reach 100. This symbol is called summation. Sigma. Summation. So now we say, okay, so we're back to here. This increments up to now 2. So we put 2 here. So summation means to add. So we add the next one, 2. Did we reach 100? No, we did not. So we keep going and we increment this up. Now we're up to 3. And you can quickly see what the pattern will be. 3, 4, 5, dot, 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 99, 98, 100. When this n reaches 100, we go, do we reach 100? Yes, that's when we end. And 100 is the last term in the sequence. So this is a summation from numbers 1 to 100. So this is a lot shorter to write. We'll get more into this a little bit later. That's not what the lesson's all about now. Okay? All right. So we're trying to add these numbers up in a sequence. What's the official formula? Well, this is what Gauss came up with. He thought the sum of the terms, notice when you add them all together, you have the number of terms, in this case 100 terms, you cut it in half, divide it by 2. You take the first term plus the last term. What's the official math definition? S for summation. If you remember, in the geometric generators was A sub n. That was the term in the sequence. Now we're doing S for sum of terms in the sequence. Equals the number of terms divided by 2, the first term plus the last term. Because if you have 20 terms of sequence, this would be the last term. Okay? So that formula is very important. That formula we're going to be using a lot. Okay, so let's try a problem at hand now that we know the special formula. Okay, so I did not erase these problems. My bad. Let me put the eraser on these real quick before I get started. I thought I did erase them. I guess not. Apologize for that. Okay. So, the directions here is to find the sum of each arithmetic series. So we're going to use the formula that finds the sum. So let's take a look at it real quick and see how well we can do on it. Let's use pen and go with green ink, red ink. Okay, so how are we going to find the sum of 2 plus 4 plus 6 plus 8 plus 10 plus 12? Yes, I would probably use the calculator if this was on the SAT. But we're not going to use the calculator because I want to show you, I want to reinforce that it works. So we'll find the sum of how many terms. Now be careful. This is the first term in the sequence. This is the second term in the sequence. This is the third term in the sequence. Fourth, fifth, sixth. This is the sixth term in the sequence. So we're going to find the sum of 6 terms. How many terms do we have? We want to do n over 2. So n is 6. Of course, we see this and this and they should match. So we have 6 terms in the sequence over 2, parentheses, multiply it by the first term in the sequence, a sub 1, 2, pair it up or add the last term of the sequence, which is 12. And that should give us a sum of the first 6 terms in the sequence. So that will be 3 times 14, and the sum of the 6 terms will be 42. Now, if you think about what Gauss thought about a long time ago, he said, I notice if I add the 2 and 12, you get 14. You add the 4 and 10, you get 14. You add the 6 and 8, you get 14. So you have 3 pairs of 14. So three pairs. You have 3 14. So 3 times 14 is 42. So it works very nicely, the formula. So now we're going to accept the formula works. Now remember, you found the sum of a finite series. Why is it called a finite series? Because it's finite. It finishes. It has an ending. It goes from here to here, no more. So find the sum of the finite series. Okay, and also let's note, I'm telling you that this is an arithmetic series. In other words, you didn't have to check. You didn't have to go for, let me use a permanent pen, sorry. You did not have to go 4, take away 2 to see common difference is 2. And then you go 6, take away 4, the common difference is 2. You all can see there was a common difference of 2 because 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. But I was very nice here. I'm telling you, it's an arithmetic series. So we can assume to use the arithmetic formula when I tell you it's an arithmetic series, but we should check just in case they don't tell us. Now, obviously, I wanted something a little bit more annoying for you to do, so I gave you a bunch of fractions to add together. So let me get my eraser because I want to erase this answer. I should have left that, but okay, I'll do the whole thing over. Sorry about that, guys. I like to have this stuff pre-done. I just messed up. All right. All right, let's take a look at this real quickly. What are we going to do? Well, what if I didn't tell you? I know I did tell you up here, find the sum of each arithmetic series. So technically it's an arithmetic series, but let's make believe we didn't know. So let's go through the whole process right now. So let's take a look at this. Let's use red. Let's do 3 quarters, take away 1/2. Okay? If you do 3 quarters, take away 1/2, it should be 1/4. So it's going to be we'd use 0.25. I like to use 1/4. Or you can try 1 take away 3 quarters. That will also produce 1/4. At the same time, the common difference is 1/4. So we know it's an arithmetic situation. So if it's arithmetic, we're going to use arithmetic formulas. What did I want to do? I want to find the sum. So we use the sum formula. The sum of n terms equals n over 2, first term plus the last term in the arithmetic sequence. So let's take a look at it. Sum. How many terms are there? 1, 2, 3, 4, 5, 6, 7. So this is the 7th term in the sequence. So we're going to find the sum of 7 terms. We do the number of terms, divide by 2. take the first term of the sequence, which is 1/2. That's the first term of the sequence. This is a sub 1. Plus the last term in the sequence. The last term of the sequence is going to be a sub 7, which is 2. So now we can successfully find the sum of the 7 terms without typing all those annoying fractions in the calculator. So it's basically 7/2 times 1/2 plus 2 is 2.5, or 5/2. So either way, doesn't matter how you do it. So let's just use 2.5, and I'll put it in the calculator as 2.5. Okay. I prefer the fractions because I can do it in my head. Calculator is a little bit more annoying to use, but the decimals, 2.5 times parentheses 7 divided by 2, and we get a grand total of 8.75. The sum of the 7 terms is 8.75. Okay? So basically what I'm saying, if you add this, plus this, plus this, plus this, plus this, plus this, plus this, there's a finite set, because that's going to change eventually. It's finite set, you get 8.75. Okay? So far, so good. Let's scoot down here to a new problem. Let's find the sum of the first 30 terms. Now, if you look at it, we're going to find the sum of the first 30 terms, but look, it goes 1 plus 5 plus 9 plus ... I was nice. I told you it was a arithmetic series, so we know we use arithmetic formulas. But let's make believe we didn't know that. Let's see if it does have a common difference. So let me come over here and do 5 take away 1. We get 4. Hard to write with a mouse. Then we're going to do 9 take away 5. And we also get 4. So I'm noticing we have a common difference of 4. When you have a common difference, we use arithmetic formulas. So you might say, well, Pasella, this is easy. We want to find the sum, so use the arithmetic sum formula. Okay, I agree with you on that. We're going to go into the arithmetic sum. So S sub n equals n over 2 a1 plus a sub n. First term plus last term. So we go through the process. We say, what do we want to find the sum of? Well, they told me up here, we want to find the sum of the first 30 terms, right? So we know we want to find the sum of 30 terms. Makes sense. Now we're going to do I did the answer. Hold on 1 second. Let me get my eraser. Okay. And let's continue on. We're going to find the sum of 30 terms. So it's 30 over 2. First term in the sequence. That's right here. That is my first term in the sequence, which is 1. Plus, a sub n. Well, n, if you look at it, is 30. See, n is 30, n is 30. So we need to know the 30th term in the sequence. We only have 3 terms, a sub 2 and a sub 3. What's the 30th term? How do we find the 30th term? Well, if you recall, there's another formula that we've used. We've used the generator. The generator is a sub n equals a sub 1 plus n minus 1 times d. Now I want to point out something to you. Very often these two formulas go hand in hand to help each other. What do we want to find? The 30th term in the sequence. A sub 30 equals the first term in the sequence, which is going to be 1, plus n minus 1, 30, take away 1, times the common difference, which we found over here already, 4. So a sub 30 will get me the generator for the 30th term. So basically it's 29. You can see 30 take away 1 is 29 times 4 plus 1 is 117. Okay? So the 30th term is 117. Now what's nice about this is we wanted this term here, the last term in the sequence. The last term in this sequence is going to be what? Dot, dot, dot. It's going to get plus to 117. And that will be the 30th term in the sequence. So we had to find it using the arithmetic generator to find it. So now we do the math. The sum of the 30 terms, if you crunch this, I believe the answer is going to be, let's see, 117 times 3, it's 118. So 118 times 30 over 2 is 15. 1770. 1,770. 1,770. That is the sum. If you add all of these plus L between up to 117, you get 1,770. See? So the 30th term was generated. We use that and to find the sum because the sum involves the first and the last term of the sequence. See? Nice job. All right. Now let's take a look at this next question here. Okay, I left the both formulas up here to save time. So let's take a look at this real quickly and see what's going on with this problem here. First, we want to find the sum of, and the directions are the same, the first 30 terms. So I don't want to rewrite that. So we are finding the sum of the first 30 terms. We are finding the sum of the first 30 terms. Okay? I'm going to write here the sum of the first 30 terms. The directions were above. I just was too lazy to rewrite it. Okay. So how do we do that? Okay. So we find the sum of 30 terms in the sequence. We have 30 over 2. Take the first term of the sequence, which happens to be -9, plus the last term of the sequence. Well, we don't know the last term. We need to know the 30th term. How do we find the 30th term? We come over here, and we're going to do a sub 30, the 30th term we're going to generate. We can do that if we know the first term plus the last term. So 30, take away 1. We need the common difference. How do we get it? We can figure it out by subtracting. Subtract any term, subtract it from its previous term. Yes, it's 2 negative signs there. So that answer is going to be a 6. If I try the 3, the negative, apologize, my bad. If you try the positive 3, subtract it from the previous term, -3, you also get 6. And you can check it. You can see that if I add 6 to -3, you get -9 plus 6 is -3. If you add 6 to this, you get 3. Okay, so now I want to figure this out over here mathematically. So our common difference is 6. So a sub 30, I am going to get my 30 terms. I'm use the calculator to get the exact answer. I think if I do it in my head, it's like 160 or 165. Let's see. 29 times 6. Take away 9. Now you get 165. So right here, the 30th term is 165. So I'm going to put 165 here because that's the last term in the sequence. Remember, it's the first term, a sub 1, plus the last term, a sub n. That's an L for the last term. I just wanted to show it a different way. So how do we find the sum of the 30 terms? Just do the math and crunch the numbers. Okay, so it's 163, take away 9. I apologize, 165. Why did I write 163? It's a 5. Fix it up real nice. There you go. 165, take away 9. 156 times 15 is 2,340. 2,340. That is the sum of this finite series. If you add these terms, and remember the last term it went up to was 165. So if you add all these terms and the ones in between, the first 30 terms, you get a 2,340, and that's the sum of those. All right. Let's take a look at this last question here. If you notice, the representation is a little bit different. I said I apologize. There's two questions here. Okay. Let's just do this one down here. I'm going to hold off on this one right now. So don't do this one here. Let me just draw a line through it. I don't want to do that right now. Okay. Let's do this one here. Eraser. Okay, let's find the sum. Okay, summation. Okay, this is the summation of k equals 1 to 200. That means k starts off at 1. So you're going to put 1 here. Did you hit 200? No. You come back around. When you come back around, is k 2? Put 2 here. Did you reach 200? No, you got to do that until you get 200. So wait a minute. How do we find the sum of this series? First, let's start generating them and see what's going on with this little formula. So, first time around, 2k is 1. I'm trying to make this tight so it fits as many as I can get in, plus 3. 2 times 1 is 2, plus 3 is 5. So the first term of my sequence is 5. That's my a sub 1. Plus, let's do the next term of the sequence. I'm going to color code it so we can see it. Plus 2 times 2 plus 3. That's my next term of my sequence. So it's 5 plus 2 and 2 is 4 plus 3 is 7. So that's my second term of my sequence. Plus, after this, you will see a pattern, and we're going to assume the pattern works nicely because it takes too long to do this. 2, remember, k was 1 all the way through. Didn't reach 200. K is 2, did not reach 200. K is 3. That's what we're up to now. K is 3. So we'll find that right now. And 2 times 3 is 6. Plus 3 is 9. Oh, I can see a pattern. These are incrementing up by 2. Now, there's no reason to go any further. We're now going to say, I want to find the sum of these. To find the sum, we think about the formula of a sum of arithmetic series because they have a common difference of 2. So it's going to be n over 2 parentheses first term plus last term. Now, I see something. I know I want 200 terms because it goes 1, 2, 3, 4, 200 terms. So we have the sum of 200 terms equals 200 divided by 2. I know the first term of the sequence. I got that right here, 5. But wait a minute. A sub n is the last term of the sequence. You did not get the last term. So how do we know what the last term is? It's pretty simple. When k becomes 200, so when k increments to 200, it'll be the last term of the sequence. So k is 200 plus 3. So this last term is going to be plus dot, 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 and we're going to add this last term, which is 403. So now we're going to add 403 to this number, because that's the last term in this arithmetic series. And we're going to do the math work. So it's 200 divided by 2. We know it's 100 times 408. And that's going to be 40,800. So the sum of the first 200 terms is going to be 40,800. Okay? And that's how it looks.